In the previous video, we have watched the magnitude of the sum of two vectors. Now we are going to look at the difference between the two vectors. Let's say A is one vector and B is another vector. The difference in them is A plus of minus B vector, which is nothing but A vector minus B vector. So let's call the difference in two vectors, especially when the vectors are opposite each other, like R vector is A minus B. What is the magnitude of the difference? The magnitude of the difference between the vector equal to magnitude of A minus B. So what are the two vectors here? If you want to visualize that vector, it will be like this. Suppose A is this vector and B is this vector, and the angle between them is theta. We call this A vector, we call this B vector. So when we say A minus B, what we actually mean is we are changing the direction of this vector. So I have drawn this too much over here, so I'll move this here. So A minus B literally means that we have to kind of, this is B, and when you give it a 180-degree rotation, what you get is minus B. So let us give it 180-degree rotation. So we have done a 180-degree rotation. So that is over here. So B was actually there. Now B is on this side. So this is going to be called minus B vector, and the angle between them, previously, I'll just use a dotted line over here. Previously B was in this direction, it has theta. Now this angle is going to be 180 minus theta. When you want to find the resultant should be drawn from A plus of minus B. It has to be drawn from here to here. So this length is the magnitude. That is what this literally means, A minus B. So the whole sort of geometrical thing, we don't need to do that. Here you just simply have to square it. So the square of the difference in two vector is A minus B the whole square. So we have already discussed that the square in the multiplication of vector, we have discussed that square of a vector. So it is, square is always a dot product. So A vector minus B vector dot A vector minus B vector. So this is A into A vector. So A vector dot A vector, and then minus A vector dot B vector, and then minus B vector dot A vector, then minus into minus plus B vector dot B vector. This is actually magnitude of R whole square. So the magnitude of R is simply R. So this is R square. So this thing is actually A dot A. So please go back and watch how A dot A is A square. So R square is A square minus AB, minus AB means A dot B, minus B dot A is again A dot B, because A dot B equal to B dot A, plus B dot B is B square, which implies R square is equal to A square plus B square minus 2 into A dot B. So we know that A dot B is actually A square plus B square minus A dot B is AB cos theta. So 2 times AB cos theta. Now all are magnitudes. So R square is this much. So R is square root of A square plus B square minus 2AB cos theta. Even if you use vector parallelogram law, we will end up having this result, but without getting into the geometrical difficulty into all these things, we can easily find the magnitude using this. So there are two things. One is the sum of two vectors. The magnitude of the sum of two vectors is A square plus B square plus 2AB cos theta. The difference is A square plus B square minus 2AB cos theta.